Here we go. We have a question k sum paths. So you have given a binary tree and an integer k. We need to determine the number of downward only path where the sum of node value in the path is equal to k. A path can start and end at any node within the tree but must follow the downward path. So, what do we mean by downward path? So, it means parent to child. So, it means, in other words, root to leaf. So, we have a path from root to leaf. So, 8 to 3 is a path, and in this path, we need to determine. So, if you can visualize it like 8 to 3 is an array, and in this array, we need to find out the number of sub arrays whose summation is equal to k. So in this path 8 to 3 we got one such subarray whose summation is equal to k, which is 4 and 3, and one more answer is 4, 2 and 1. So in the explanation it is clearly visible. 4 to 3 is a path 1, then 4 to 3 is another path whose summation is equal to 7, which means k, and 5 to 2 is one more path whose summation is equal to k. But if I can say 3 to 1, 3 to this minus 2, is this a path? No, this is not a path. Is minus 2 to 1 is a path? No, it is not a path. Is minus 2 to this 2 is a path? No, it is not a path. Path must start from root node till any leaf node, and in this so we can say this is an array, and in this array we need to find out this sub array whose summation is equal to k. So in this example we need to find 3. So this 3 node individually is summation k, and 1 to 2 is one another part whose summation is equal to 3. Now let's build the approach. So I have taken this example. So before that there's a prerequisite. So let's suppose we have given an array. So 2, 3, 1 and 4, and we need to find out the summation, the k whose summation is equal to 4. So I hope you are already aware, if we have a current and if we find current minus k in the array, it means current is also there. If till here we got current and this is current minus k, then the remaining portion is our k, and this is another subarray. Then we need to find the number of subarrays whose summation is equal to k. If you are not aware, let me quickly explain you how we can find. If till here we got summation as k, so this is my current summation. Is summation minus k there in my map? We will use map for this. So the key will be element, and the corresponding frequency and the corresponding value will be frequency, the number of time that element occurs. So till here we got 3 is till here we got 2 is 2 minus 4 there, which means minus 2 is minus 2 there. No, it is not there. So just to simply put current value with the corresponding frequency. Till here we got 5, and we need to find out current minus k, which is 5 minus 4 is there. No, it is not there. So directly put the value and move to the next element. We got 6 is 6 minus 4, which means 2. Is 2 there? Yes, 2 is there. It means current minus k is there. In the array. This is current minus k. It means k is also there. Till here we got current. So if your current minus k is there, that current minus k, that many times k is also there, that many times k is also there in the array. So we got answer as 1. Now let's move ahead. So answer is 1. So we will move to the next value. 6 plus okay. I missed one thing, which is to insert this value, then move to next value, so 6 plus 10, so 10 minus 4, which is equal to 6. Is 6 there? Yes, 6 is there. Till here current minus k, which means 6. Till here the value is 6, so then the remaining value is k, which is equal to 4. And we have found one more subarray, but we have not tackled the edge case. There's an edge case that we have just missed. So what's the edge case? So let's suppose we got the same example, and here the value is 5. So till here we got 2. Is current minus k there? Which means current 2 minus 5 minus 3. Minus 3 is not there. So just put the value and move ahead. Till here we got 5. And is 5 minus 2, 5 minus 5 0. Is 0 there? No, 0 is not there. But this subarray makes the summation as k. So we have not tackled this situation. To tackle this situation, we can do two things. Either we can put 0 with frequency 1 initially before iterating, and one more option we have is to check if current is equal to k, is to separately check if current is equal to k, then update your answer. So I am not a big fan of this thing. I will just insert 0 with frequency 1 initially. Now it will help us. Is 0 there? Yes, 0 is there in our map. So we have found one such subarray. Now current is 1. Now let's move to the next element, and before that just insert this. Don't forget to insert the value. We got 6, so 6 minus k, which is 1. Is 1 there? No, 1 is not there. So put the value 6 and 10. So 10 minus 5. 10 minus 5 is 5 there. So 5 is there. So this is 5, and we have found one more k, and we will increment our k. We will increment our answer. Answer will become 2, and in this array 2 subarrays are there, and we have also tackled the edge case. So that's all I want to discuss. Let's build the approach for the binary tree. Same condition, same thing will apply here. So you can consider this as an array, and while going this way, if we go on this way, we will just remove the elements. If we go on this way, we will just remove the element that we have inserted. So we don't really need to create a separate array. We can just utilize the array. We just need current variable. So till here the current variable is 1, and we have 0 with frequency 1 initially. Our answer is also 0, and we need to find for current minus k. Is 1 minus 5 there in the map? No, it is not there. So put the value and move on to the left side. Summation is 3. 3 minus 5 is there? No, it is not there. Put the value and move it. 6 minus 5, 1. Is 1 there? 1. Yes, 1 is there. So if your current minus k is there, it means your current is also there. So we have found one such subarray. Put the value. Yes, we have found one such subarray. Put the value and move ahead. Move on this side. So we got 8. Is 8 minus 5, which is equal to 3. Is 3 there? Yes, 3 is there. It means we have found one such subarray, and one more. It means current minus k is there. so it means your k is also there. So if your k is also there, that many times current minus k is there, so k is also there that many times. So just increment 1, value becomes 2. Insert, move on to the left side, null, move on to the right side, null, return back. So then we have this thing, return back from this position. As we are returning back from this position, we don't really have 8 path. So 8 frequency will decrement by 1. 8 frequency will decrement by 1. Next we move on to the right side, null. Then we are returning back. As we are returning back, just decrement the frequency by 1. Decrement the frequency by 1. Next we are on to this location. Move to this side. So 4 is 4 minus 5 there, minus 1 is not there. Okay, increment the frequency and insert it. Move on to this path, 5. So 5, we got 5. So 5 minus 5, it is there. Yes, 5 minus 5 is, it is there. So we have found one more subarray. So that's why it is helpful to directly put 0 with the frequency 1 initially before iterating. So we have found one more subarray and increment the frequency. Move on to left side, null, move on to right side, null, and we are going back from this position. We don't really have 8 on the other side. So 5, we don't really have 5, so just decrement the frequency by of 5 by 1. We are on to this side. What's the value will be 6. So is 6 minus 5 there? Yes, 6 minus 5, 1 is there. So if 1 is there, it means k is also there. If current minus k is there, it means k is also there. So then increment the frequency. We have incremented the frequency and we are on to 6. So just add 6. Okay, we already have 6. So 6 frequency will be incremented. Then we are on to this side, null, return back, null, return back. Then we are returning back from this position. So 6 frequency will be decremented. Okay, then we are going back from this position. So 4 frequency will also decremented. Then we are going back from this position. 3 frequency will also decremented. Then we are on to this path. We got 5. So 5 minus 5 is there. Yes, one time it is there. So one time just update answer and insert, move on to left side, null. Okay, move on to right side. We got 14. So we got 14. Just check. 14 minus k, it is there. 14 minus k, 5. 14 minus 5, which is 7. 7 is not there. Okay, move on to left side, null. Move on to right side, null. Going back from this position. So if I have updated my, if I have added my current, it's time to remove the current frequency. So current frequency getting removed and we are returning back from this position also. So 5 frequency will also getting decremented. Then we are going back from this position. 1 frequency will also getting decremented. And that's it. What are the steps? Step 1 is to calculate current. Step 2, check current minus k. Then check, then insert current into map. Then the next step, this is backtracking. As we are going back from left and right, and we are going back from the current node itself. So it's time to remove, not remove, just decrement current frequency. That's it. That's the four steps that we need to follow. Let's code this. So we need a map then we have a recursive function. We need root, the current summation, map and k. And what I will do, I will just make integer function, return, its return type is integer. Then we have node till now current sum. We need a map as a parameter and k, but we missed one thing, which is to put 0 initially with the frequency 1. If your node is null, this is the base case, we directly return 0. Then calculate your current sum. This is the first step. Calculate your current sum, node dot data. Then the second step is to check map dot get or default. If current minus k is there, it will get the value, otherwise it will get 0, or get the value from the left side or on the right side. Node current map and k. And before going on to this step, we need one more thing, which is to insert the value. So if current value is there in map, just increment the frequency. If current key is not there, so let me rephrase it again. If current element is there, increment the frequency. If current element is not there, put current element with frequency 1. So to do this operation, we have two things. Is first of all put or get to default, or another thing is have merge function. So if current frequency there, it will just increment the frequency by 1. So if current frequency is not there, it will put the frequency with -1. And we also need backtracking, so with value -1. If current is there, so let me explain it one more time. If current is there, it will add frequency by 1. If current is not there, it will put frequency by 1. That's it. And at the end, just return the answer. So let me try this, if this work. And we got TLE. Why we got TLE? Because in the recursive function, we are not calling left or right child. We are calling the same node again and again. And I hope it will work now. Yes, let me submit this. Now let's talk about time and space complexity. So in this function, I think we have made a mistake here. What thing I have missed? One, two, three, and we need to find. Okay, one. We need to find for 2. Yes, we are getting 0, but this is the expected output. Yes, I have written minus. We need to write plus here, not minus. That's the stupid thing I have made. This is the mistake. I hope it will work now. Yes, let me submit this. So let's talk about time and space complexity. In this, the time complexity, what will be the time complexity? We are onto a node only once. We are visiting a node only once. So its time complexity is pretty straightforward. It is order of n. What's the space complexity? we have a map and we have recursive stack. So recursive stack will store order of height, and map will also store order of height elements. And we have made the expected time and space complexity. If you guys have any doubt related to this question, feel free to ask in the comment section. Give this video a thumbs up, subscribe to this channel. Code is provided in the description box. Thank you all for watching.